Hey guys, it's Mr. Dorado here starting another video for you guys, and today we're going to be talking about real world applications of every single thing that we have been doing for this chapter, okay? So we're basically wrapping up the chapter with real world situations that we can go ahead and use our linear equations for, and we are going to go ahead and try to reach that objective today. So our objective is to model real-world situations with linear models. So let's go ahead and define what linear models are. So a linear model is a representation of a real-world situation that can be modeled using a linear equation. So just like the ones that we have been using this entire chapter, okay? And now just as an extra note here, I would write where variables represent particular quantities or units. Okay, so in these real world scenarios, we'll notice that we'll see a lot of units being talked about in the particular problem, and we will also go ahead and represent those units as variables in our linear model. Okay, so just to go ahead and recap here, we have our our two forms of writing a linear equation. We have slope-intercept form or point-slope form. Now, over here on the very right, we have the equation of how we can find the slope if we ever need to calculate it if we are given 2 points. Now, because we are talking about real-world scenarios here, I want to make sure we go over, just like we did in chapter 1 and actually chapter 2 as well. M is our slope. Okay, now slope, okay, in a real world problem, we will see some keywords such as per, every, or each. Okay, so if you see any of these words, more than likely they are representing slope. Okay, another word you might see for slope might be rate, because if you remember, guys, slope is a rate of change. Okay, now for B, in a slope-intercept form, you will see things like starting value or initial value. Okay, so just so you know, look out for these words to represent our variable of b. Okay, so let's go ahead and get started with our first problem. So I want to go ahead and look at a sloped intercept application type problem. So let's go ahead and read through this and see if we can answer the questions. So let me grab my highlighter here. It says Miss Wojcik started out with 12 gallons, so I'm going to go ahead and start highlighting a few things that I think might be important. So Miss Wojcik started out with 12 gallons of gas in her new car. As she continued to drive away from the dealership, her gas decreased at a rate of 0.05 gallons per mile. Okay, let X represent the number of miles, so X represents miles, and then Y, let me actually use a different color, Y represents total gas. Okay, so actually I'm going to go ahead and write myself a little note of that last sentence off to the side here, because we might need it in our final answer. So X represents the number of miles, and Y represents total gas. Okay, so let's go ahead and see what's being asked of us in part A. So it says, Write a slope-intercept equation that models this situation. Well, let's go ahead and see if we can find any of these keywords that we have up here. So we said that for slope, for m, we can either look for the word per, every, or each. And actually, we can actually look for that word as well, rate. Okay, remember it's a slope. It's a change in y over a change in x. So let's reread the problem real quick, see if we can find any of those keywords. As Ms. Wojcik started out, well, actually, even before finding my slope keyword, I already found my keyword for my B, right? I started out with 12 gallons. So what I'm going to do here on the side is write B equals 12, okay? And then it says she started out with 12 gallons of gas in her new car. As she continued to drive away from the dealership, her gas decreased at a rate. Here's that keyword I need for slope, and that's the rate it decreased at. So remember, if it's decreasing, do I use a positive slope or a negative slope? Well, in this case, I have to use a negative slope of 0.05. So I have everything I need to make my linear model. So it has to be in y equals mx plus b. So it's y equals negative 0.05 x plus b, which in this case is 12. Okay, so again, let me actually slow down a little bit. What did we do? It's asking us to write a slope-intercept equation, right? A slope-intercept equation that models the situation. So for that, I need a slope and I need a y-intercept. We talked about earlier that these keywords up here tell us which is our slope, or our m, and right there, actually right here, we found the rate, which was 0.05, and it was decreasing. That's why my slope here was negative 0.05. And also right at the beginning of this problem, we saw the word started, which is one of our keywords for our B term, and it was 12 gallons. Okay, so that's why my B here is 12. All I did at that point is substitute those values into my y equals mx plus b form to get this right here. Okay, so let's go ahead and skip down to part B. Now it says how much gas will be in her account after driving 10 miles to get home. So even before I answer this question, I want you guys to understand the reason why we do like to write linear models like we just did. We just wrote this situation, or this equation that models the situation above. So now we can answer these types of questions, okay? But we have to remember, again, what do each of those variables represent? What does the y mean and what does the x mean? Well, we wrote those two things up here. Y is the number of miles, X is the number of miles, Y is the total amount of gas. So I'm going to go ahead and actually rewrite my equation, but then I'm going to go ahead and read this situation, and we might have to do a little bit of substitution. This says how much gas will be in her account in her car, not her account, car, after driving 10 miles to get home. So what was I just given? I was given 10 miles. And we said that x is representing miles. So this 10, I'm going to have to substitute in here. Okay, so let's go ahead and do that. So we get y equals negative 0.05. Instead of an x, now I'm going to put a 10 plus 12. Okay, if we multiply that out, we get negative 0.5 plus 12, and then we get y equals 11.5, and this is in gallons of gas. Okay, so we have our answer. So again, guys, the reason why we make linear models like that is to be able to answer these types of questions. If we wanted to know how much would be left after 80 miles, then we can go ahead and just substitute that into the x value. Okay? Alright, so let's go ahead and look at a situation that would be in point slope form. Alright, so let's go ahead and read through this scenario, see if we can identify all of our information. So it says, Miss Lupo jumped out of an airplane and pulled her ripcord. Gravity pulls her to Earth at a speed of 98 meters per, see that per right there, that's going to be a keyword, and then it says at 13 seconds, she was at a height of 1,000 meters. Write a linear equation that gives the height, which is going to be y, which is in meters, and also x represents seconds. Okay, so let's go ahead and see how we can write this model. Okay, so it says, what information can you gather from the word problem? Can you set up any ordered pairs, or do you know the slope? Well, let's go ahead and look up here real quick. We know that to find slope, we need to look for one of these keywords, and I saw per. Per is one of our keywords here, right? We saw it right there. Whoa, that's not good. Not the color I wanted. Okay, let me use a different color. So per is right there. So my slope in this situation is 9.8, but remember, gravity is pulling her down to Earth, right? So her slope or her rate of change is not positive, it's actually negative because she's coming down. So it's a negative 9.8. Now, this is a point slope equation or a point slope application. So we need to be able to model using a point. So can you set up any ordered pairs? Well, let's see. The only other numbers I see here are 13 and 1,000. So in a new order pair, so my point, what goes where? Well, let's see. X, which is in seconds, X represents seconds. So where do I see seconds here? Seconds is right there. So X goes here. Y goes in the second one, which is in meters. So I see 1,000 meters here. So I have everything I need to write a point slope equation. So let's go ahead and write one down. So we know it has to be in this form. So let's go ahead and write it. It would look just like this. So y minus y1, which is 1,000, equals negative 9.8, parentheses x minus x1, which in this case is 13. Okay. Now, next thing says, write a slope-intercept equation to model this situation. Well, we already have a point slope, so all we really need to do is distribute and solve for y. So let's go ahead and do that. So we had y minus 1,000. So I'm just using the equation from up above. Let's distribute. I get y minus 1,000 equals negative 9.8. And then negative 9.8 times negative 13 is a positive 127.4. From here, add the 1,000 to isolate the y. So what do we get for our final answer? We get y equals negative 9.8x plus 1,127.4. So this is our final answer for part C. Alright, now with that model, we can answer the next question, which asks, how high was she off the ground when after 20 seconds? So again, let's figure out what is seconds. Is that my x or is that my y? Well, I see it right here. X represents seconds, so I actually have to substitute in 20 in for x. So let's go ahead and do that. So it's y equals negative 9.8 parentheses 20 plus 1,127.4. If we multiply that out and add the 1,127.4, you should get a final answer of 931.4, and then this, we want to know how high, and we were talking about meters. Always use your units on these problems, guys, okay? Especially with real world scenario problems, you definitely want to make sure you use units because different variables represent different types of units, so you need to specify which one you have. Okay, so again, I just want to do a quick recap of what we did to make sure we understand everything. For part A, we were asked to identify an order pair and the slope. We did by looking at a few keywords. That gave me my slope, the 13 seconds and 1,000 meters. We know those represented x and y, as I highlighted down there, which is my x and y right here, which are my two coordinates for that particular point. Once we had that, we can write a point slope equation like was asked here, which we did right there. Then we were asked to find a slope-intercept equation, which basically just asked us to take that point slope we had earlier and finally rewrite it in slope-intercept form. Okay? Now, to help answer the rest of these questions, guys, I need to make sure that you guys understand and can use this hint I'm about to give you. Okay? So, when you do one of these problems, go through it and either highlight or circle all the numbers that are significant to the problem. Okay? So anytime you see any numbers, just like I did up above, just highlight them or circle them. Okay? Now, this is very important. If you see two numbers, then you have a slope and a y-intercept. Okay? If you have three numbers, then chances are you are given again a slope, but this time you were given a point. Okay? Because a point has two different coordinates, an x and a y, and the slope, which is represented by m, so that's three numbers. Okay? And then finally down here, the number in its own sentence is the slope. That's usually how it works. There's not really a rule. However, in these types of problems, you'll notice that the number that's on its own, all by itself, is usually the slope. And maybe if you see two numbers together in a sentence, that's more than likely representing a point. Okay? But again, remember guys, and I'll do another little quick reminder here. Always look for key words. Okay? Always look for keywords, like we wrote up top. Okay? Alright, let's go ahead and try out 1 and 2, and then I'm going to have you try 3 and 4 on your own. So let's see what we got. So I'm going to go ahead and circle these with you guys because I know you guys probably don't have highlighters, so I'll go ahead and circle them along with you. So it says, Kim has a contract with her cell phone company that gives her a number of anytime minutes. But if she exceeds the number of anytime minutes, she has to pay 7 cents for each, and I already see a keyword, so I'm going to underline it, for each additional minute. And again, notice that one, we know it's a slope, not only because I saw the word each, but look, that 0.07 was in its own sentence. Okay? But let's keep going. Then it says, last month, Kim had 120 extra minutes, and her total bill was $53.40. So 120 minutes, and her bill was $53.40. Notice how those two were in the same sentence. More than likely, we have a point here. Okay? So it says, let x represent the number of minutes. So x represents the number of minutes, and y represents total amount. Okay, so let's go ahead and circle anything that we know we were given. Well, right here we said that we saw the keyword each, which means that 0.07 was our m, was our slope. Okay, so m equals point, whoops, 0.07. Okay, and also we were given a point here because look, we have two numbers and we're on the same sentence, so we can go ahead and write a point. Well, how do we write our point? Well, we have to identify what variable represents what, because remember, our point has to be x comma y. So let's see, x represents the minutes, so that would be 120. So this one's going to be 120. And our y represents the total amount, so that's the 5340. Okay, we have our point, we have our slope point. Now, we want a slope-intercept equation, so first we're going to have to write a point-slope equation, then we can go to slope-intercept. So let's go ahead and write our point-slope equation, which would be y minus 53.40 equals 0.07 x minus 120. Okay, from there all we have to do is distribute because we want a slope-intercept equation, not a point slope. So we get y minus 53.40 equals 0.07x minus, and I believe this is a 45. No, I'm moving on ahead on here. Let's see. I did too many calculations at once. This is an 8.4. Okay. Now what we have to do is add 8.4 to both sides. So what do we get? We get y. What am I doing? Sorry about that, guys. I got distracted over here. We have to add the 53.40. Okay, so I get y equals 0.07x plus 45. There we go. Much better. So is this in slope-intercept form? Yes, it is. So this is our linear model. Okay. Part B just asked, 1 month Kim had a bill of $50.95. I'm sorry, $50.95. How many extra minutes did she use? Okay. So this right here was her total for that particular month, right? A total. Okay, and we said that y represents the total. So what I'm going to do is substitute that 50.95 into my y from my slope-intercept form. So I'm going to have 50.95 equals 0.07x plus 45. Go ahead and subtract 45 from both sides because I'm trying to find x, which represents the number of extra minutes. So I get 5.95 equals 0.07x. Let's divide by 0.07 to get a final answer of 85 minutes. Alright, don't forget your units on here, guys. Okay, then last part here. How much will the bill be if she has 200 extra minutes? Well, again, what variable represents minutes up here? Let's double check. The variable that represents minutes is x. So now, once again, let's reset. Let's use our original linear model here and then substitute the 200 into our x. So what do we get? We get y equals 0.07 parentheses 200 plus 45. Okay, let's multiply that out, and then if we add the 45, see if typing it all in here, we get 59, and then remember, this is in dollars. So our answer here is $59. Alright, I think we'll try one more together, and then you guys are off on your own to try out the last two. Okay? So it says, your job at Herb's clothing store pays you a base salary of $1,000 a month, plus a commission rate of 7% on every item you sell. So right away I already saw a few keywords here. So let's go ahead and remember, we have a base salary of 1,000, okay, and you get commission at a rate of 7% on every item you sell. Okay, let X represent the total amount you sold, and Y represent the total paycheck amount. Okay, let's go ahead and identify what we have here. Well, right away here, let's go ahead and, where was it? Every, we know, represents our slope. So that 7%, okay, is our slope. So we definitely have a slope here. And also, we have a base salary, so like a starting initial salary of $1,000, okay? And what did we say is a keyword, or initial or starting represents what? Well, if we go back up here, starting and initial represents our B, which is our y-intercept, okay? So it represents our y-intercept. So what do we have? A slope-intercept equation already. So that'll be kind of nice. We can go straight to writing our equation. So 7%, remember we need it in decimal if we want to use a linear model. So if you turn it into a decimal, all you have to do is take 7 divided by 100. You get 0.07. And B is our y-intercept, which in this case we said was 1,000. So if I write my equation in slope-intercept form, I get y equals 0.07x plus 1,000. Alright. Part B says, on your last paycheck, you receive $1,150.05. What was the dollar amount sold? Okay, so your paycheck was $1,150. And what represents the amount on your paycheck? Y represents that amount. Okay, so what I'm going to do is I'm going to substitute that number into my Y from my slope-intercept form. So I get 1,150. 0.05 equals 0.07 x plus 1,000. Okay, so now it just becomes a matter of solving for x. So let's go ahead and do that. So first thing I have to do here is get rid of my 1,000. Again, you're using SADMAP here. Don't forget the regular basics on solving equations. So what do I get? I get 150.05 equals 0.07x. So if I divide both sides by 0.07, I get, let's see, let's type it into our calculator. 0.07, I got $2,143.57. Remember, guys, we are talking about money here, so you need to make sure that you only go to the hundreds place. So only 57 cents. You have to round. Okay? Last problem says how much will your check be if you sell $2,500 in items? Okay, so let's go ahead and see. What variable represents the amount of money in items? That would be X. So now I'm going to reset, take my original equation that I had up here, and instead of putting that 2,500 in Y, I'm going to actually put it into X this time. It's going to be Y equals 0.07 parentheses 2,500 plus 1,000. Okay, if you multiply that out, let's see what we get. Let's see, 0.07 times 2,500 is 175 plus 1,000. We get $1,175. Don't forget your units. So $1,175. Alright guys, so again, before you start trying out number 3 and 4, remember these 3 things right here, guys. Make sure you remember them. If you see 2 numbers in the entire problem, it's probably a slope and y-intercept. If you see 3 numbers, it's probably a slope and a point. If you see a number that's all by itself in one sentence, it's probably just the slope. And then always look for those keywords that we wrote up on top of the page to help you identify which is which. Okay? So go ahead and pause the video right now and try out number 3 and number 4. Alright guys, let's go ahead and see if we can identify all the information in problem number 3. So it says Ricardo is draining his pool for the winter. There are 240 gallons in the pool and it is decreasing at a rate of 20 gallons per hour. Okay, I saw that right there. Rate and per, those are good clue words for slope. But let's continue highlighting what we have. Let X represent the number of hours that have passed, and Y represents the amount of water left in the pool. Okay? And remember, we are draining the pool, so you are decreasing at a certain rate. So keep that in mind when we write our slope. Okay, guys? So, like we said, we have these keywords here. Whoops. We have those keywords there that help us represent our slope. So we know we definitely have a slope, and that slope is 20. And don't forget, we're draining it, so it's a negative 20. And then what else do we have? It says there are 240 gallons in the pool right now. Okay, so at the starting point, before it starts decreasing at a rate of 20 gallons per hour, we had 240. So if it's the starting value, then that's actually our y-intercept. That's our b. So this is 240. Okay, so we actually were given a slope and an intercept, which is kind of nice because that's exactly what they're asking us to write here. So let's go ahead and write it. We have y equals negative 20 x plus 240. Okay, so we have our linear model now. Let's go ahead and use it to answer the rest of these questions. So it says, if there are only 100 gallons left in the pool, how many hours have passed? Well, what variable represented gallons? Let's go back up. Gallons of water was represented by my y, right? My amount of water. So that's where I'm going to substitute in those 100 gallons. So I have 100 equals negative 20x plus 240. We solve just like any other problem. Subtract 240 to both sides. What do I get? I get a negative 140 equals negative 20x divide both sides by negative 20, and I get x equals 7. But remember, 7 what? What are we talking about? X represents number of hours. So here, x equals 7 hours. Okay, and finally for part C, how long will it take to completely drain the pool? Okay, now, hint, how many gallons will there be if it is completely drained? Well, I'll give you guys a second to think about it, but I think you guys can figure it out that if you drain the entire thing, then you will have 0 gallons left. Okay, and again, which of these variables represents gallons? Well, once again, it's the y. Okay, the y represents the amount of water in there, so I'm going to substitute in 0 in for y. So I have 0 equals negative 20x plus 240. Okay, we have to subtract the 240 on both sides because I'm solving for x. So I get negative negative 240 actually, equals negative 20x. Divide both sides by negative 20. We get x equals 12. Okay, and x represents what? It represents the number of hours. So don't forget to write in your units. Okay, alright, let's take a look at this last one. So double check your work for problem 3, guys. Make sure you guys had a correct linear model and were able to substitute the right values in the right place. Okay, now let's go ahead and look at this last one and we will be done for this chapter. Or sorry, for this unit. So it says it costs a company $12 in parts. So I already see some numbers here, so let's highlight them. In parts to make one DVD player. The total cost of making 300 DVD players is $4,175. Let X represent the total number of DVD players and Y represent the total cost of the company. So, as we remember from our top hint, okay, it says the number that's usually by itself is the slope, which in this case would be the 12 right here, okay? So it makes sense that this is my slope. And what other information was I given here? Well, it says it costs 300, the total cost of 300 DVD players is 4,175. Those two are in the same sentence, and because I see a total of 3 numbers in this entire problem, then we more than likely have a point and a slope. So that last 2 sets of numbers will help represent my point. So my M was 12, my point, remember, has to be x, y. Okay, so what does x represent? X represents the DVD player, so this has to be 300, and y represents the cost, so this has to be 4,175. So again, guys, remember, there was exactly 3 numbers here, so the only scenario we have is that it's a point and a slope. Okay, but what are we being asked to do? We're being asked to write a slope-intercept equation. So we want something in y equals mx plus b. Well, we can't do that yet. We have to get to that point. But we do have a point and slope, so let's write a point-slope form. So this is y minus 4,175 equals 12x plus, minus 300 actually. Okay, this is our point-slope equation. We need to use that to write a slope-intercept. So let's go ahead and distribute. So we get y minus 4,175 equals 12x minus, and I believe this is 3,600. Next step is add the 3,600 to both sides. Whoops. No, I want to isolate the y. I actually have to add the 4,175 to both sides. So what do I get for my final answer? I get y equals 12x. Let's go ahead and add those two numbers up. So I get 4,175. I got $575. Okay, so here, this is our linear model. We can now use that for part B and C. So it asks if the cost of the company is $31.20, how many DVD players were made? Well, we know that the cost is represented by the Y, so that's where I'm going to substitute that in. So I have 3,120 equals 12x plus 575. All we're doing now is solving for x. I get 12x equals, go ahead and figure what that is. That's 2,545 divided by 12. We get a total of, well, that's actually, I don't think that's a whole number, so let's try it out. That's 2,545 divided by 12. We get 212.083. But remember, guys, we are talking about DVD players here, so it only has to be a whole number. So you can say something like approximately 212 DVD players. Okay, so x equals approximately 212 DVD players. Last problem, or last part of this problem is if only 50 DVD players are made, how many would it cost the company? How much money would it cost the company? Let's go ahead and try that out. These 50 DVD players we know represent X, so I'm going to use Y equals 12 parentheses 50 plus 575. Get Y equals, that is, let's see, so 12 times 50, I believe that's 500, or 600, but let me check. 600 plus 575. So we get a total of Y equals $1,175. Okay? Alright, now these problems are pretty time consuming, guys, but again, if you break these down into certain steps, then you should have no problem completing them. Remember, and I'll go ahead and scroll all the way back up here. So first what you have to do is identify the information you're given, right? So this is what I wanted right here, your huge hint. If you see two numbers, it's probably slope and y-intercept. If you see three numbers, then it's probably the slope and a point, okay? And then the number that is all on its own sentence is the slope, and you should always look for the keywords, okay? So this is the main part when solving all of these problems. Go ahead and identify all the values you were given, and then go through this checklist to identify what you need to do next, okay? Alright guys, I think that is it for today, so I'm going to go ahead and finish the video here, and go ahead and try out the homework for 3.6 day 1 and see how you do on those, okay? Alright, well I will talk to you guys later. Bye.